Hey everyone, and welcome. If you're diving into your CCNA studies, or you're just curious about how the internet really works under the hood, you are in exactly the right place. Today, we're going to crack the code on two of the most fundamental frameworks out there, the OSI and TCP/IP models. We're going to start with the big question. Why do we even need these models to begin with? Then, we'll walk through that classic 7-layer OSI blueprint using a really simple analogy to make it all click. After that, we'll look at the modern TCP/IP stack that basically runs everything. And finally, I'll give you a super handy trick to make sure it all sticks in your brain. Alright, first things first. Why do we even bother with all these layers and models? Well, it all comes down to solving a huge fundamental problem in the world of technology. I mean, really think about it for a second. You've got literally countless devices made by thousands of different companies running totally different software. And yet somehow, my Windows machine can send a message that your Android phone can read perfectly, no problem. How is that even possible? Without some kind of common set of rules, it would be total digital chaos. And this is where networking models come to the rescue. They are the elegant solution to that chaos. You can think of a model as a shared blueprint, or maybe a common language. It takes the massive, super complex job of network communication and breaks it down into smaller, much more manageable pieces, or layers. This is what allows vendors like Cisco and Apple and Microsoft to build products that, can actually talk to each other. So, to really understand this whole layered approach, we have to start with the granddaddy of them all, the OSI model. Now, here's a key point. It's not what the modern internet actually uses day to day, but its vocabulary and its concepts are absolutely essential. Think of it as the conceptual guide that laid the groundwork for everything else. And here they are in all their glory, the famous 7 layers developed by the International Organization for Standardization, or ISO. We've got application way up at the top, layer 7, and it goes all the way down to the physical layer at the bottom, layer 1. The big idea here is that each layer has one specific job to do, and it only talks to the layers directly above and below it. Okay, I know what you might be thinking. Application, presentation, session. What on earth does any of that actually mean? Trust me, to make this all feel intuitive, we're going to use a super simple analogy that really helps. Just sending a plain old physical letter. So, just imagine you want to send a letter to your friend Bob. It's a simple, everyday thing, right? But this process maps surprisingly well onto those 7 layers of the OSI model. Let's start at the very top, layer 7, the application layer. This one's easy. It's simply the content of your message. It's you with a pen and paper writing the words in the letter. In the digital world, this is your email or your request for a web page. It's the data itself. Okay, next up is layer 6, the presentation layer. This is kind of like the universal translator. You're writing the letter in English because you know Bob reads English. You wouldn't write it in a secret code he can't understand. This layer handles stuff like data formatting and encryption, just making sure the device on the other end can actually make sense of the data. Then we have layer 5, the session layer. This is all about managing the conversation. It's like calling Bob beforehand and saying, "Hey, I'm sending you a letter," and him saying, "Cool, I'll look out for it." This layer opens, maintains, and then closes that communication channel between two devices. Alright, layer 4, the transport layer. This is a really crucial point. You don't just send the letter to Bob's house, right? You address it to Bob. So if anyone else in the house gets the mail, they know, oh, this one's for Bob. This layer does the exact same thing using something called port numbers. It makes sure the data goes to the correct application on the other computer, like your web browser, not your email client. Moving on down to layer 3, the network layer. This is the big picture, the final end-to-end destination. In our analogy, this is you writing Bob's full street address, city, state, and zip code on the envelope. It doesn't care how the letter gets there, it just cares about that ultimate endpoint. In the real world, this is the job of the IP address. Now, this is a subtle but super important distinction. Layer 2, the data link layer, does not care about Bob's house. It only cares about the very next hop.
That's it. This layer handles local delivery from one device to the very next one using MAC addresses. And finally, we hit the foundation, layer 1, the physical layer. In our analogy, this is the actual physical stuff, the paper, the roads, the mail trucks, the airplanes. It's the infrastructure that physically moves the letter. In our world, it's the copper cables, the fiber optics, the Wi-Fi signals, the actual hardware that carries our data as electrical signals or pulses of light. And TCP/IP model. As you can see here, the TCP/IP model we actually use is a lot more practical. It basically looks at the top 3 OSI layers, application, presentation, and session, and just squishes them together into one single application layer. It just recognizes that in the real world, the application you're using usually handles all that formatting and session stuff itself. The bottom 4 layers, though, they map over pretty much one-to-one. Okay, there is a critical concept you absolutely have to understand, especially for the CCNA. It's called encapsulation. As your data travels down the stack from application towards the physical layer, each layer adds its own little wrapper or a header. It's kind of like putting your letter inside an envelope and then putting that envelope inside a mailbag, and so on. And this whole process of adding wrappers has special names you just have to know. At layer 4, our data with its new header is called a segment. Then, when that gets passed down to layer 3 and gets another header, the whole thing becomes a packet. And finally, at layer 2, it's wrapped up one more time to become a frame. You have got to remember those 3: segment, packet, and frame. It's crucial. All right, I know that was a ton of theory, so let's wrap this all up with a couple of practical takeaways to help you lock this stuff in, both for your exams and just for your career in general. First off, you absolutely have to know the 7 OSI layers by heart. Here's the classic mnemonic that everybody uses, going from the bottom up, layer 1 to layer 7. Please do not teach students pointless acronyms. That's physical, data link, network, transport, session, presentation, application. Seriously, it's a lifesaver. Okay, so we've talked about all these abstract layers, which brings us to the most important practical question of all. How does this relate to the actual hardware? You know, the boxes with the blinking lights you're going to be configuring. Where do things like switches and routers fit into this picture? And here it is. This is the crucial link for your CCNA studies. A switch is a layer 2 device. It makes all of its decisions based on MAC addresses, handling that local hop-to-hop delivery we talked about. A router, on the other hand, is a layer 3 device. It makes its decisions using IP addresses, figuring out that end-to-end path across the internet. Understanding which device lives at which layer is the key to,